like to acknowledge Fiona Impson, who's actually the biological control specialist. I'm more interested in how we can use biological control in the management of alien plants in the park if it is making an impact. Yeah. So I don't need to tell you that alien plants are the third biggest threat to biodiversity in South Africa. But what all of you might not know is that they contribute to about 25% of the loss in biodiversity in South Africa. They utilize about 3 to 5% of the water in South Africa. And research has found that they exacerbated some of the water losses or the droughts in Cape Town, and they contributed to the excessiveness of the fires in Knysna because it added about 15% to the fuel load. As a result, we have one of the biggest alien plant clearing program, and we spend quite a huge amount of money as well as labor that is utilized in managing alien plants. We spend about 1 billion a year towards invasive species, but despite these efforts, we are still not able to actually quell alien plants. This is because the alien plants are able to spread about 5 to 10% a year, while we are able to only reach about 2 to 3% of the actual areas that need clearing. So mechanical clearing as well as chemical cannot quell alien plants alone. So we need to adapt or we shall perish. So integrated weed management is actually our next best step, and biological control is actually an important part of that. So what is biological control? And it is the use of natural enemies of these weeds that either suppress the growth or the spread of the invasive plants. And in South Africa, we utilize insects, fungi, and pathogens. So we have about 9 biological control agents that have been released so far for acacia weeds. These are 5 seed feeding weevils, 2 bud gall forming wasps, as well as 2 midges that form galls as well. So why do this project if there has been studies already that have said biological control actually works? Is because most of the work has been done in either the Cape Floristic region or in a broader region. It doesn't actually help us with actually coming up with tangible management plans or at the local scale to basically plan or utilize biological control. And because biological control is not like herbicides, the impacts also vary across different, across regions because they are dependent on bottom-up effects, you know. So this is why I wanted to start this project. The project is still in its early stages, and I was looking at whether gall-forming alien biological control is able to attack or suppress reproduction in these plants. So for now, I actually looked at 3 alien plant acacia invasive species, and what we found so far is that on average for black wattle, about 85 to 100% of the flowers had galls, so they were able to suppress reproduction in that species. And when we look at Acacia longifolia and Acacia stricta, the results are quite different. With Acacia longifolia, it was about 20%, at about 20% to 60%, they were able to suppress reproduction, whereas with the Acacia stricta, this was very low. And so what can we learn from this? Because we just started collecting data. The project is still ongoing. It seems that acacia for biological control for Acacia longifolia as well as Acacia mensia, biological control is working, but not so much for Acacia stricta. It is not surprising for Acacia stricta because it currently doesn't have a biological control of its own, but this biological control was released for Acacia cyclops, and then it jumped from that to Acacia stricta. So what can we do with these results? What are they saying? So we need to maybe use a more flexible strategy, as biological control seem to have varied between sites and between species. So maybe prioritize areas where biological control is working, and maybe in the areas where biological control is not working, then we can use mechanical and chemical clearing. Thank you.